think we're ready to start. Welcome to CS251, also called Intermediate Software Design. I'm Doug Schmidt, and I'll be giving an overview this morning of some of the things we'll be covering in class, and then I'll be turning it over to my co-instructor Christoph, who will be delivering many of the lectures in the course, and he'll be giving you an overview of what we'll be covering in the class, and he'll also give you a quiz, so you get to start off the semester on the right foot. I was at the Commons 2 nights ago talking to the engineering freshmen. They have an orientation. Some of you may remember that from when you were here. And one of the questions that everybody asked was, will there be a quiz on the first day? And there is. So I don't think they'll have one, but you guys do. So the goal here is to kind of talk about what the course is about, give a few ground rules, and then give you a brief overview of what we're going to be covering from a technical point of view. We're also going to be doing an experiment this class, which we'll see how well it goes or not. We'll be recording the videos, and then we're going to try to post them along with the slides up on the website so you can follow along, and if we talk too fast, or if you miss class, or you zone out, or you just want to hear it repeated again, you'll be able to watch the videos. We'll see how well that goes. So a couple things. One of the things that you're going to find out in this class is that there's a lot of programming. And if you like programming, you will love this class. If you don't know if you like programming, this is your time to find out. If you absolutely hate programming, then you're going to have quite an adventuresome next 14 weeks. One of the things that you'll have to make sure you do is pace yourself. And I'll repeat this now, and I'll probably say it again a couple times. Do not wait until the last minute to start your assignment, because you will just absolutely die. So make sure you submit the assignments on time. Christoph will talk a little bit more, and I'll talk a bit more about how that process is going to work. The work in this class has to be your own. It's not a project course. We look at the assignments very carefully, and so things that you do that are plagiarism are usually pretty easy to detect. So make sure you don't do that. Every once in a while we have to end up taking people to the Honor Council because of plagiarism. In the class, one of the key rules, no laptops open. It's been my experience after teaching this class for a decade that people who pay attention do very well on the quizzes. They do well on the assignments. People who sort of don't pay attention or don't come to class do very poorly. And nothing is more frustrating than going over this material in great detail and then having people not be here or not pay attention, and they come to office hours, they ask questions that reveal that they didn't pay attention. So make sure that you pay attention. You can go back and watch the material if we get our production working properly, and that'll help you a little bit more to understand what's going on. One of the key things that's also important in this class is participation. We have a reasonably big class here, and the goal by the end of the class is to get to know everybody's name. That happens a couple different ways. It happens by passing the quizzes back, which is a good time to get to know people's name, because we have to figure out who you are to pass the quizzes back to you. Come to office hours, send emails, ask questions through email, or ask questions through the Piazza website, which you should all be informed about by now. Make sure you raise your hand, ask questions, and so on. Very important. Don't just sit there like a bump on a log. It's not fun for anybody. As I mentioned before, this class is a lot of work. Inevitably, after teaching this class for a long time and reading the student evaluations, most people say, worked a lot more in this class than most classes, but I got a lot out of it. And so that's the goal. The goal here is to make sure that you're given a lot of feedback and mentoring on how to be effective as a software developer. We'll have weekly quizzes. The purpose of the quizzes is to make sure that you're keeping up with the material. People always say, how do I study for the quiz? For the most part, the information on the quiz pretty much comes right out of the lecture notes. So as long as you're following along and understanding what we're covering, you'll be in pretty good shape. Once again, don't sit there as we talk about stuff and it is whizzing by you and you're like, I don't know what's going on. Come to office hours, write questions on Piazza, send us email. Whatever you need to do, ask questions in class. Do not let yourself get behind. Do not let yourself be confused, because you'll be very frustrated. We'll have lots of programming assignments. We'll talk more about that. Occasional guest lectures. Christoph's going to do the bulk of the lecturing. He actually TA'd the class for, I think, 6 semesters, so he's extremely knowledgeable about the material, and I'll also be here as much as I can. You'll also have lots of people who are graders and TAs to help out in office hours. All the TAs in the class are people who've taken the class before and have done very well. One of the things we like to do in this class is find the next generation of TAs and graders. So if you enjoy this and you want to keep doing it, there's lots of ways to get involved. So those are some other things. The basic philosophy of this course is the following. You don't learn how to become a good software designer. You don't learn how to become a good software programmer just by reading a book or by listening to high-level abstract discussions about concepts and principles. You learn how to be good at this stuff by practice, by application, by doing it yourself, applying the concepts, getting feedback from people who know how it works. And what we're going to be focusing on in this course primarily to help you get that experience is severalfold, but the most important theme by the time we're done with the class is the concept of a pattern, and I'll talk more about that. That's really at the core of what this course is about. We'll also cover a lot of other topics related to becoming a good programmer, programming techniques, object-oriented design, object-oriented programming, generic programming, and so on. So you've got a good, well-rounded coverage of this stuff, but the key theme is going to be about learning how to recognize common structures and behavior in software that's been identified by experts who've been there for a long time, and then learning how to apply those good concepts to your own code to make you more effective. And I absolutely guarantee you, even if you know a lot about programming, even if you know a lot about object-oriented design or C++, you will learn a lot of stuff in this class that you didn't know. The main theme of this, the main purpose of this, is to learn how to write code that is not just correct in the sense of meeting the functional specification, but is also well designed, has quality, able to be understood, able to be maintained, able to be reused, modular, etc., etc. And a lot of times people, especially if you've done programming before, let me ask you a question. How many people here have done much programming before? Aside from just taking 101 and 201. So have you programmed, either in high school or projects? So about half the class or so. One of the things that you discover as you do a lot of software development is that an expert looks at the problem quite a bit differently than a beginner does. Just like an expert who is a good chess player, or an expert who's a good martial artist, or a good athlete, or a good dancer, or whatever, a good musician. They attack problems, they do things in a different way. When I was first learning to play guitar back in high school, they would teach you all kinds of things about how to keep your fingers curved and your thumb behind the neck, and you practice scales and stuff like that. And then you go and you watch footage of Jimi Hendrix playing at Woodstock. And he's like playing with his thumb and all this stuff, breaking all the rules. He didn't quite look at it in the same way that the beginners do. There's a reason why you do those things as a beginner, because you have to get started somewhere and you have to learn some good habits. But the key thing is to practice and practice and to watch what other people do and to get background and basis from their expertise. We're going to be applying a lot of these techniques to learn how to build good software, to learn how to document software, to learn how to test software. That's one of the other themes we're going to cover a lot in this course, is effective testing. It's not enough anymore to be a good software developer just to write code. You also have to know how to write the unit tests to make sure the code does the right thing and things don't change out from underneath you as you make modifications and enhancements and optimizations to your implementations. So unit testing is important. Christoph will talk about that. And some of the key themes that we're going to see here are the concept of object-oriented design and programming in the context of reusable classes and frameworks. And so you'll get a chance, especially by the end of the course, to get a lot of experience with frameworks. And patterns are here to help you learn the good practices and the role models in this space. We're going to assume that you know something about C++. Something that you know about C++ is something that you would have learned in CS 201. That's one of the goals of the quiz that's going to come here shortly, to see what you remember from 201. That'll help us do a better job of knowing how much time to spend on introductory material. In my experience, people who learn C++ in 201, even people who are good at it, often have a lot of things that they still need to improve upon in terms of how to write robust code. And so we're going to spend a lot of time talking about how to write robust C++ code, how to write code that's exception safe, how to write code that's going to be more efficient than would be the case if you just sort of did things in a somewhat naive way. And so you'll get a chance to learn a lot about that. We'll also be talking a lot about C++ 11, which is the latest version of the C++ standard, and also something called the Standard Template Library, or STL, which is a really powerful toolkit that has become quite pervasive, and it's really the way that modern C++ developers approach their craft, by using STL. And you'll see it's got a somewhat different perspective than traditional object-oriented design. All the programs in the course will be in C++. we're going to be using the GNU G++ compiler for the submission. Let me rephrase this. So you're welcome to use various tools to write your code. We have our own preferences. Christoph will talk about that and show you some examples. But by the time you're going to submit your code, you have to make sure that it compiles properly and links properly and runs properly with GNU G++. And the reason for that is that it is a much more strict implementation of the C++ standard, especially C++ 11, than you're likely to find with other environments. Another nice thing about G++ and Linux, which kind of comes along for the ride here, is that you can use certain tools for finding faults and memory problems in your code, things like Valgrind, which is going to be a lifesaver as we get to the more sophisticated parts of the course where we're dealing with pointers and we're dealing with arrays and variable-sized objects and structures and so on. And the use of this tool called Valgrind, which works nicely with G++, will save you many, many hours of frustration trying to chase down the inevitable memory corruption and buffer overflow problems that you run into when you program in C and C++. So it's good to get accustomed to programming with that. The programs themselves will be graded according to a certain set of criteria. One of the most important things that you have to do is make sure your program compiles and runs properly. If you submit code that doesn't compile and doesn't run, if you submit code that doesn't compile, we don't even grade it. You get no points at all. If you submit code that compiles but doesn't run properly, you lose 40%. This is why it is absolutely imperative to start the assignments as soon as they're released. Do not wait to the last minute, because you'll discover, especially as things get harder, and they'll get harder pretty fast, that the things that you're asked to do here are sometimes subtle and tricky, and if you wait to the last minute, you will not be able to figure out how to get it to work. So you're much better off starting early and then coming in and asking lots of questions to see how things work. Other things that we grade on really have to do with appropriate style, appropriate commenting, appropriate design structure, and just ways to make your program easier to understand, easier to read. For the programs you've written to this point, most of them have probably been fairly small, maybe a couple hundred lines at most, at least the ones you wrote in class. If you've done other programming, you've probably done more than that. But if the courses, the kind of programs you've written in 101 or 201, they're pretty small. By the time you get done with this class, the final assignment, which is a sequence that we do, will run upwards of around 3,000 to 5,000 lines of code, which isn't big by any stretch of the imagination, but it's a heck of a lot bigger than a couple hundred lines of code. And one of the things you discover as you're doing that is if you don't comment your code properly, you don't structure it properly, you will have a hard time understanding what it does. And even if you can keep that crammed into your short-term memory for a short period of time during the course, what you discover over your lifetime of programming is you go back and look back at your solutions you did a couple years ago, and you'll be absolutely befuddled as to what they do. And as you start working, if you work professionally, even if you do research related to software, you'll have code that lives for a long time, and you'll have to be responsible for maintaining it in some way. I still have code I wrote back in the late 80s that's widely used in a lot of systems. And when I go back and look at that code, I was a grad student when I wrote it, I'm ashamed and shocked at how crappy it is. And it's terrible. I didn't understand good software design. I liked to program. I was a good programmer, but I didn't understand design. I didn't understand a lot of these concepts. And one reason I didn't understand them was that nobody ever really mentored me in being effective at writing this software. So that's a lot of what this course is about. We're also going to spend time going over solutions. After every assignment is due, we're going to go through and show you what not to do. It's like those TV shows like, How Not to Dress or whatever. This is what not to do, how not to write the solutions. And by seeing what, and that'll be based on things that you guys are doing. And so by getting the feedback, anonymously of course, it'll help people understand what students are struggling with. People often make mistakes in similar ways. And so part of our goal is to really mentor you and demonstrate through example how to do it right. You got to turn your program in on time. If you don't get it on time, no grade. We're going to have weekly quizzes starting later today. There'll be a final exam. Here's the relative weighting of the various things. Programming is really important. The quizzes are really important. Final exam is just a small part of the grade. In-class participation is about a letter grade's worth of stuff. So if you don't participate, you're dropping a letter grade. If you don't show up for class, you're dropping a letter grade. So don't do that. Show up to class. This is an exciting time to be here at Vanderbilt. This is a great course. You're going to get a lot more attention here than you're going to get in other courses often, so take advantage of it. All right, all office hours will take place in Featheringill Hall 226, which is right on the other wing over there. Take a look at the course website, and the course website is here. We'll keep this up later. my.vanderbilt.edu/fall 2013 CS 251. Let me write that on the board just so that when we move past this slide, you can still remember how to get there.
Professor, does that mean we don't use Oak at all?
You do not use Oak, no. At least for this class. You can use it for other classes, obviously. There you go. So that's where all the stuff will be. And that'll tell you where to go. That'll tell you who the TAs are. It'll tell you when their office hours are. All the TAs for the class, as I mentioned before, have taken the class. All the TAs for the class have been TAs for the class before. And you will find them a font of knowledge about this. And if for some strange reason we have to evacuate the building, there's the evacuation plan. I think you can run out that door. So it's not, you don't have to go very far. Okay, so we're going to two more things. I'm just going to give you a quick overview of a little bit of stuff, a little technical stuff. I'm going to turn it over to Christoph, and then we're going to do the quiz. The quiz should take 20 minutes-ish at the end. So the language for the course is C++. I've been programming with C++ since the mid-'80s. So it's been almost, gosh, it's hard to believe, it's been almost 30 years of C++. I've done a lot of work with C++. I worked on the original GNU G++ compiler way back in the day. That's where some of that crappy code came from I was telling you about. And I've watched C++ evolve over many, many, many years. C++ started out as a better C. It started out as adding classes and data abstraction to C. We'll learn more about what this means as we move down through the course. Over time, lots of other cool things have been added. Support for so-called virtual functions, which is something called dynamic binding that works in conjunction with something called inheritance. We'll spend some time on the class on that. That's important. You've learned about that probably a tiny bit in 101 and 201, maybe just a tad. You'll learn a little bit more here. The more interesting thing in C++ these days is templates and parameterized types, which are the same thing, and that's used to provide support for a programming paradigm called generic programming. That's going to be a big focus of this course. You're going to learn some cool stuff here that is really cutting edge. There's lots and lots of other things in C++. C++ 11 adds a whole pile of new stuff. And a lot of the things that have come along in C++ over the years are not so much in terms of language features, but in terms of additional capabilities added to the standard library for C++. So there's various things in there for doing input and output. C++ 11 provides support for multi-threading and synchronization. We're not going to talk much about that here. There's string classes, there's matrices, graph classes, then there's the standard template library itself. The standard template library is a really fascinating exercise in applying some of the core patterns we're going to be covering throughout the course. We're going to be covering things like adapters, iterators, strategies, factories, and so on. Those are all core parts of C++ standard template library. The 3 or 4 key concepts in STL are containers. If you took 201, you probably got a little bit of exposure to container-like things because you learned about data structures like heaps or vectors or stacks or queues or linked lists, etc. Those are containers. There's a bunch of things called iterators that you can use to go through a container one element at a time, forwards or backwards or in some other order. And then there's algorithms which work on the iterators to access and potentially modify the elements of the container. And there's some other stuff too, like functors and allocators and so on. You'll get a chance to play around with a lot of this stuff. Last couple things. Oh, I should also mention that how many people here are taking the course for grad credit? Wow. Okay, 1, maybe 2. That's interesting. So the graduate students in the course get to do a little bit of extra work because that's what it means to be a graduate student. You get to do extra stuff. And so sometimes we'll be presenting the results and we'll talk about the undergrad version. We'll show the solution there, and then we'll also show the graduate stuff as well, just to give you a sense. We also tend to sometimes stagger the assignments. So the grad students will do something in one assignment and the undergrads won't have to, and then the next assignment the grad students have to go off and do something else, and then the undergrads do what the grad students did in the previous assignment. So you get a chance to learn. Oftentimes people who take this course who are very good at programming, who would be bored with the assignments, they're welcome, as undergrads, you're welcome to do the grad student stuff as well. That's not uncommon at all. And for those who really like to program, I encourage that. So the other key topic of the course are patterns. Patterns represent solutions to common problems that arise when you build software in a particular context. Obviously, we're going to be talking about the context of software. There's lots of other contexts in which patterns apply. I'm not going to belabor them right now and go through them in detail, but we'll talk about this later when we get into the patterns part of the course. There's absolutely fascinating examples of patterns in civil engineering, patterns in athletics, just all kinds of stuff. And understanding how experts work, as I mentioned before, is crucial to see how they've mastered patterns. We're going to be using patterns to help resolve certain characteristics or non-functional forces that affect the way that software is designed and evolved. So we're going to be dealing with patterns to make software more flexible, more reusable, more modular, more extensible, more efficient in some cases. And so by the time you're done, you'll have an understanding of these concepts, but much more important than the concepts, you will have applied these concepts over and over and over again throughout the semester with greater and greater degrees of complexity and specificity. And so by the time you're done, you'll actually have learned maybe a dozen or so patterns from the book we're going to be using. Patterns capture recurring roles and responsibilities that relate to how software is developed and applied and reused, and it helps to capture good ways of structuring solutions both statically and dynamically, both in terms of the static structures and their dynamic communication and interactions in the way that you build software. Sometimes these things sound abstract at first. I guarantee you when you start writing the code and you look at the patterns we'll be covering, they'll make a lot more sense. I should also mention that we have a whole video series of material I recorded last year when I taught the class in the spring for a portion of the course. The portion of the course is going to be the patterns part of the course, and we'll post the URL you can go to look at the videos if you're interested in watching them. They won't be 100% consistent with what we're covering, but it'll be awfully close. And so it's a good place to learn and get experience and exposure to more information that you can absorb. Back in the early days of software patterns, people only documented a handful of patterns, the so-called Gang of Four patterns. You'll learn more about Gang of Four patterns later. Over time, over the past 20 years, many, many more books have been written about patterns in lots of other areas, lots of other languages, lots of other domains, lots of other contexts. And we'll not cover a lot of those in this course, but it's worthwhile being at least aware of the fact that there's a very, very rich literature of other information that you can go and study and absorb. Patterns are just the beginning, though. Individual patterns in isolation are powerful, but it's not really the end goal. Patterns work best in groups, and what's useful about this is you can use groups of patterns, which are called pattern languages, to help document the way complex software architectures are going to be put together and how they're going to address the requirements, both functional and non-functional or performance-oriented requirements, for when people build software. And you'll see that pattern language, which we'll actually cover in the last part of the course, gives you a vocabulary, which are the patterns themselves, and it also gives you a process for applying these patterns in order to resolve different kinds of software design challenges and programming challenges. Again, some of this stuff will seem very obscure at first, but when you get into it, you'll be, I think, quite interested to see how it works. And by the time you're done with the course, you will have your own vocabulary of patterns will have been greatly magnified, and you'll be able to communicate more effectively with each other or with people if you work in summer internships, or just yourself as you look at the code you wrote later to understand not just how it works, but why it works in that particular way. So with that as a background, and then there's frameworks. We're not going to talk much about that. Frameworks give you three things. They are a form of systematic reuse that gives you inversion of control. The framework owns the event loop and it calls back to you to do certain things. They give you domain-specific structure and functionality in either application domains or infrastructure domains, and they give you essentially semi-complete applications where you have to fill in the blanks to do the actual business logic of the code. Anybody here ever written a smartphone app for iPhone or Android? Oh, great. So if you've programmed in either of those platforms, you have used frameworks galore. iOS and Android have lots and lots and lots of frameworks, so that will be very natural to you. You'll get a chance to learn perhaps more systematically how they work. I also want to give a brief advertisement. Anybody here in Vandy Mobile? Great. So one of the things that I think that we're actually changing the name this year now, it's called Vandy Apps. So we're trying to generalize beyond just the mobile part, but that'll still be a big part of what we're doing. So there's a student organized club that we have here that is basically people in computer science and computer engineering and other parts of campus who are interested in getting together and doing cool things with software. And I very strongly encourage you to get involved. There's lots of things you can do in that context. You can get to know other people here who are more experienced, who can help to mentor you. You get great exposure to local companies that are looking to have people come on as interns or consultants and so on, and help them out and get paid either during the school year or during the summer, and that's been great. You also get lots of opportunities to be involved with entrepreneurship. I'm the chair of the Technology Entrepreneurship Task Force here at Vanderbilt, and one of the things we're really doing is providing much greater opportunities for undergrads especially who are interested in starting companies or being involved in startup companies. And there's actually a donor who's given some funds, and Vanderbilt students who are undergrads, or grad students for that matter, who are interested in more entrepreneurship type things, you can actually go down to the Nashville Entrepreneur Center, which is just downtown near the stadium. Actually it's right near the convention center, the new convention center. You can go down there, and there's a Vanderbilt berth down there, and you can go and work with people and get access to various leaders, innovators, venture capitalists, and so on. And a lot of our best and brightest students over the past 4 or 5 years have done this, and they've started companies. They are doing really cool things either here or elsewhere. So I strongly encourage you to get involved with the Vandy app activity. And one of the things that we're very happy about is we're now able to start offering courses that are complementary to the themes of Vandy Mobile or Vandy app. And so CS 281, CS 282, the course I'm teaching this semester as well, CS 278, 279, all the stuff that we're doing there is a lot more oriented towards teaching people their skills and techniques related to mobile devices and cloud computing and all the kind of things that are really cutting edge. So this is cool. Okay, so I will turn it over to Christoph, and he will give you an overview of what you can expect to come. And let me give you the mic. Yep.
Thank you.
Yeah.
All right, so my name is Christoph. Some of you may remember me from 201 last semester. That's a lot of Z's in my name that I don't tend to pronounce anymore because Americans or other non-Polish people aren't good at that. I also tend to go by KZ a lot, just the initials, because typing my name and signatures takes too long. All right, so I'll be doing some lectures this semester. And before we go into that, how many of you have registered for Piazza? All right, how many of you haven't? All right, so we'll be using Piazza as the communication center for the class. Anything that any other student could benefit from should go in Piazza. So try to avoid emailing the TAs or the instructors directly, since then we have to spam everybody else to deliver that response. So get on Piazza as soon as possible. When the website goes up, this link right now points to a work in progress page, so it's not very useful. When the website does go up, I'll put a post on Piazza, and I'll probably just send that straight to your inbox. So it's a very important tool that we'll be using all over the semester. All right, that being said, all the actual lecture PowerPoints and the videos will still be linked at the website. And we'll also have a little summary of what happened each class. So if you do happen to miss a lecture, you won't be too far behind. But as we mentioned before, you should not be getting accustomed to skipping class, because it's not going to reflect well in your grade at the end of the semester. All right, so historically I have 2 quirks that don't work well with taping lectures. Actually 3. I like pacing around, and I like to talk to students instead of talking at students. We'll see how the camera works with that. I also have a bad habit of cursing, so if that bothers you, let me know. I'll try to avoid that so it's not documented forever. All right, so this is a rough semester outline that we have up here. The class will be divided more or less into 3 sections. The first couple of lectures we'll do a brief C++ review, the history and the evolution of how we got to C++ from C, or C with classes. We're going to review some object-oriented programming skills, the big 3 or 4 or 5 or 6, depending on which ideology you subscribe to and which standard you're using. Virtual method, inheritance. We're also going to cover unit testing and build systems. So like Doug mentioned, we'll be using a unit testing framework. If you want to go ahead and start reading up on it, it's called Google Test. and it's the Google Test for C++. It's a really nice framework that makes, oh wow, that makes unit testing really nice and easy and almost self-documenting. So if your code fails, you'll get a nice little report saying this is where it failed if you write good test code. And we'll review that on the this is a Tuesday, Thursday class, on next Tuesday. We'll also have a brief build system lecture, so basically making sure that you guys understand the difference between a linker and a compiler, a translation unit and files, and how they all work together, as well as some of the quirks of C++ preprocessor, all the pound includes and pound defines type of stuff. And then we'll move into make files. So we've historically been providing you guys with make files, so you can just go ahead and type in make at the Linux prompt and compile your files into the final executable, but compile them efficiently. So you know, don't update files that haven't changed, that type of thing. So we'll walk through that. Okay, and that brings me to probably the most important point of the logistics. How many of you have Linux on your machines?